Hello, grade 11. This is our second online lecture. In this lecture, we are going to revise together what we have learned last year about functions. So let us start with the first activity that says that for every real number x whose square is x squared. Okay, so we have a function, sorry, f of x. It's the square of x, which is x squared. It's called a function. So we say that f of x, so no more y. Okay, so instead of having y, we have f of x. F of x is the image of x by f, and x itself is called the antecedent of f of x. Let us do this activity. We have g, it's a function that associates a real number to its double. Okay, so what's g of x? G of x is 2x. Why it's 2x? Because they said it's double means 2x. What's the image of 0 by g, of 1 by g? So they are asking you about the image. So they want g of x, where x is 0. So g of 0 is equal to 0. If you just replace x by 0, 2 times 0 is 0. And g of 1 is 2. So they ask you about the image, so they want g of 0, g of 1. They want you to calculate g of minus 1 and g of half. So you replace x by minus 1 and x another time by half. Okay, so we get g of minus 1 is minus 2 and g of half is 1. Now they want the antecedent. What's the antecedent? X. Okay, so they want x where the y is 6 and the y is 5 over 4. So now we have g of x equals 6. So 2x equals 6. Okay, means x is 3, and 2x equals 5 over 4 means x equals 5 over 8. So when they ask you about the antecedent, means they want x. And now if we have a curve and we need to calculate from the curve everything that we need. First of all, we need the domain of definition of h. You know what's the meaning of domain of definition? Is where the function starts and when does it end. So as you can see here, if you follow the pink line or the pink curve, it starts from minus 2. It's obvious, right? So it starts here from minus 2, it passes, then it stops at 3. So the domain of definition, every time you need to find the domain of definition, you have to look at the x-axis and not the y-axis. So from the x-axis, it started from minus 2 and it ends at 3. So the domain of definition is from minus 2 to 3. Now what's the meaning of h of 2? So the antecedent is 2. So I follow 2, I go for the curve. When the x is 2, the y is 3. The antecedent of 1. Okay, so what do I have to do? The antecedent of 1 is minus 2, because if you go for 1, okay, you get, sorry, for minus 2 here, that's the point. So the antecedent of 1 means the image is 1. So what's the antecedent is minus 2. So after applying the previous activities, let us talk about the function. So what's the meaning of a function? A function is a relation where every element of E admits an image in F, denoted by y equals f of x. So as I told you, instead of y, we're going to get f of x. So for every x, there is one y. The set of elements of E having an image by f forms the domain of definition. Okay? Let us continue. So as I said before, the function, it's a type of relation where there's exactly one output for every input. So if you have an input, it should go to an output. I will use the graph to make you see. So here we have x, for x equals 1, y equals 6. And also for x equals 1, y equals 7. For x equals 2, y equals 7. Is this a function? This is not a function. Why? Because as I told you before, for every input there is only one output. So 1 cannot have two values, 6 and 7. But 6, it could have two values, 1 and 2. So this is a function. Now, as you can see here we have a function, and it starts at x1 and it ends. So this is a function that has different values here, as you can see. Now, how can I check that this is a function or not if we have the curve? Okay, look at this curve. This is a function because if you draw a vertical line, did you see the vertical line? So when the vertical line passes throughout the function, it only cuts the line in one point. So if the vertical line, if you draw a vertical line and it cuts the curve only in one point, so this is a function. This is another function. So we need to draw a vertical line. As you can see here, if you draw a vertical line all over this function, it only cuts the function in one point. So this is a function. This is a function. If you draw a vertical line, it will cut it into many points, right? So this is not a function. This is not a function. This is another function. If you draw a vertical line all over the function, as you can see, it only cut it in one point, so this is a function. This is another curve. Let us check if it's a function. You draw a vertical line all over the curve. So as you can see, it cut it into 2 points, so this is not a function. Another example, you draw also a vertical line, so this is a function. This is not a function because if you draw a vertical line, it will cut the curve into 2 points. Also, this is not a function because if you draw a vertical line, you're going to get 2 points in common, so this is not a function. Now we're going to remember together the parity or the symmetry of a function. Suppose we have a function. This function is said to be even if there exists f of minus x equals f of x. So if you replace x by minus x and you get the same function, then this function is said to be an even function and it has an axis of symmetry, which is y prime or y. So as you can see here, this function is said to be an even function because the y-axis itself, okay, it's the axis of symmetry of this function. Now this function is said to be odd if f of minus x equals minus f of x. Okay, and in this case, the origin O is the center of symmetry. As you can see here, this function is said to be odd because O, it's the center of symmetry of this function. So this is an odd function. By the way, a function could be neither even nor odd, but there are special functions. They are said to be even or odd. So sometimes it could be even, odd, or neither. Okay? So, as I said, an even function have the y-axis as a symmetry. So everything to the left is exactly the same as everything to the right. So this is an even function that applies f of x equals f of minus x. Now, odd function, they have the origin as symmetry. F of x equals minus f of minus x. So if you just look at this figure, what can you tell? Is it even or odd? So from the graph, you have the y prime or y as an axis of symmetry. So this function is an even function. Now we have this function. As you can see here, this is an odd function because the origin O is the center of symmetry. Now let us check each function if it's even, odd, or neither. The first function, we have the y prime or y as an axis of symmetry, so this is even. The second one, we don't have y prime or y or 0 as center of symmetry, so it's neither. The last figure, we have O, the center, is the center of symmetry, so this is an odd function. Now, what if I don't have a figure and I need to prove if this function is even or odd? Let us start by even. So if you want to check if this function is even or not, you have to plug minus x into the function. So instead of having x, you have to replace it by minus x. Suppose we have a function f of x equals 3x squared minus 10, and I need to check if it's even or odd. So I replace the x by minus x. So f of minus x equals 3 into minus x squared minus 10. This will give me back 3x squared minus 10, so the same function. So I can tell that f of x equals f of minus x. They are the same. So this function is an even function. The same thing if I want to check if it's odd. Also, I plug in minus x as we did before, and then I multiply the whole function by minus. Okay, I multiply it again by minus, so it gives me back the same function if I multiply again. So I did first f of minus x, then I multiply the whole function by minus. It gives me 4x cubed minus 5x, which is the same. So this is an odd function. Now let us replace this function to check if it's odd, even, or neither. So first of all, I do f of minus x. It gives me again the same function. So this is an even function. Now let us check f of minus x. It's 4 into minus x cubed plus minus x squared. So this is, for the first time, it's not an even. Now let us check if it's odd. So I multiply the whole function by minus. It will not give me the same function again. So this is neither even nor odd. Also, I replace it by minus. So I get this. So this is not even. I multiply it again by minus, so I get 12x cubed minus 6x, so this is an odd. Now the symmetry. As I told you before, if it's an even function, we have an axis of symmetry. The axis of symmetry, it could be y prime or y, or x equals 1, or x equals 2, or x equals 3. Okay, so the general equation of this symmetry, of this axis, is x equals to a. So if I need to prove that this straight line is an axis of symmetry, I have to do this rule. Okay, so I replace a by the value of the axis of symmetry, and I check if it is an axis of symmetry or not. For example, here the axis of symmetry, it's not y prime or y, but it's also a vertical line. Okay, so x equals a is the equation of symmetry. Now the center of symmetry, it's usually a point. It has coordinates a and b. So if I want to check if it's the center of symmetry, I have to replace it in this equation. Okay, so for example here, this center I, it has coordinates a and b, and it's the center of symmetry. Sorry, here we have this function f of x equals x squared minus 4x plus 3, and you need to find its domain of definition. This is a polynomial, so the domain of definition is going to be minus infinity to plus infinity. And here you have f of minus 1, f of 0, f of 1, f of 2, f of 3, f of 4, f of 5. So these are particular points. Okay, when we calculate them, you will get, for example, minus 1, 8, 0, 3, 1, 0, 2, minus 1, 3, 0, 4, 3, and 5, 8. And you plot the points on the curve, so it will give me this curve, as you can see. If you just plot these points on the orthonormal system, you will get the function. So as you can see here, we have x equals 2. This is the axis of symmetry of the function. Now we have to prove that x equals 2 is an axis of symmetry. Okay, I told you the rule is f of a 2a minus x. It should give me f of x. So you replace a by 2. 2 times 2 is 4. 4 minus x. What's the meaning of f of 4 minus x? Means every time you see x in the function, you have to replace it by 4 minus x. So instead of x here, we're going to put 4 minus x squared minus 4 into 4 minus x plus 3. If you just expand this, it will give you x squared minus 4x plus 3, which is the same as the original function. So you can tell me that this axis of symmetry is an axis of symmetry to the function. Now here we have another function, which is x minus 4 over x minus 2. Find the domain of definition. How do we find the domain of definition? This is a fraction, so I have to take condition x minus 2 different than 0, right? So x different than 2. So the domain of definition is minus infinity to union 2 plus infinity. Now we need to prove that I to 1 is a center of symmetry. There's a rule. f of or h of, because this is h of 2a minus x plus h of x, it should give me 2b. 2b means 2 times 1 equals 2. So we replaced a by 2. 2 times 2 is 4. 4 minus x. Also, every time you see x, you have to replace it by 4 minus x. So 4 minus x minus 4 over 4 minus x minus 2. It gives you minus x over 2 minus x. Now, you have to add it to h of x. If you add those two together, if you do, you take here minus, so it becomes x. So you put it on the same denominator, it will give you 2. And 2 is 2b. So we have proved that this is a center of symmetry to the function.